All right, so as a quick review, right? Right, we need to be able to find the parametric, right? Real simple. All we have to do is write A as a variable, X, Y, and Z, and make it equal to this, which is 2 plus 4 lambda minus 1 plus lambda, 2 plus lambda, right? 2 plus 4 by lambda minus 1 plus lambda, 2 plus lambda. And then when we reach here, we can say that X is equal to 2 plus 4 lambda, Y is equal to minus 1 plus lambda, Z is equal to 2 plus lambda. This here is the parametric form. Okay? Vector equation of a line, parametric form. That's okay? That's it. Next step is to get the Cartesian. All I have to do is what? Make lambda the subject. So lambda is equal to X minus 2 and 4. If I make lambda the subject here, I'll get Y plus 1. If I make lambda the subject here, I'll get Z minus 2. Right? So the Cartesian form is this. X minus 2 and 4 is equal to Y plus 1 is equal to Z minus 2. All right? Are you okay with that, right? This is what we did last day, right? Wait. If you look at the Cartesian form, right? How you just find the direction vector? Look at the Cartesian form. How do you find the direction vector? By just looking at it. By the way, this is called the direction vector here, right? If you don't remember that from last week. What you do? What you do? Look at the what? That's called the denominator, no equation. Right? So if you look at the denominators here, 4, 1, and 1, that will be a direction vector. If you change the sign of these values here, that will be your point on the line. That's okay? All right. So you want to take a look at something called skewness. By the way, how you know two vectors parallel again? Right? So two vectors are parallel if they are multiples of each other, right? But what do you look at? Do you look at the point or do you look at the direction vector? Yeah. Right? Remember that last time we set up that, right? So by looking at the direction vector and checking to see if they are multiples of each other, that's how you know the parallel. Okay? Today, we're going to look at something called skewed lines. Okay? Today, we're going to take a look at something called skewed lines, right? Yes, sir. Yes. Was that why? That's fine. All right, so watch this here. Let us say Darian, right? All right, so watch here. How do you know if lines are skewed? Lines are skewed if they are not parallel and if they do not intersect. All right. So parallel lines, right? look like that. Intersect might look something like that. But what does skewed look like? So what you see, I want you to envision it as a 3D diagram, right? How do we draw lines that will never intersect and are not parallel? How will that look? Right? Remember, it's 3 dimensions, right? So let's pretend I have lines that are looking like this. If it's parallel, they'll never meet, right? If they intersect, they're not skewed. But how do I draw two lines that will never meet and not parallel?
Wait, they never meet and not parallel.
Never meet and not parallel. So what? If I have a line here and I put a line in front like this, will these two lines ever meet? This line going down, this line going like that, right? They're not parallel, so they will never meet. But remember, there's a 3D diagram, right? So these lines will never meet. So if I draw a line on this plane here, if I draw a line on the XY plane, right? And I draw a line on the, let's say the ZX plane, something looking like something going down, slant a little bit like that. These two lines will never meet. They're on different planes. There's not 2D diagram, it's a 3D diagram, right? So if I draw a line like this and a line like this, these two lines will never meet. Right? There's a space between them. See that? These two lines will never meet. These two lines are said to be skewed. Okay? So for example, if your lines are not parallel and they do intersect, then they're skewed. So let's see if we can figure out how to determine if lines parallel and if lines intersect. All right? That's okay? Remember, these are different planes, right? If I draw them on a one-dimensional diagram, of course, they will meet, right?
Really?
One dimension, yeah. If I draw this here,
I didn't know.
this will meet.
Yeah. That's exactly right.
Are you ready? Copy this down. I want to show you how to use term. Oh, let's take a small note on this now. I kind of gave it last week. Copy this down. Right. Take a small note. Lines are parallel. Yeah, you got space for them. Lines that are parallel. Lines that are parallel, their direction vectors are multiples of each other. Lines that are parallel, their direction vectors are multiples of each other. Next one, if lines intersect, if lines intersect. If lines intersect, then if lines intersect, then they have a point in common. They have a point in common. All right, so so I'll give you 3 lines here. Let's determine which lines are parallel, which lines are skewed, sorry, which lines intersect, and well, which pair are skewed. All right, so we're gonna look at these lines, pair them up, and check and see who's parallel, who intersects, and who's skewed. Copy them down, come when you're ready.
Right.
All right, so let's start with the easiest now. Let's start with line 1 and line 3. Sorry, which lines are parallel? Jacob. Which lines are parallel? Line 1 and 2, line 1 and 3, line 2 and 3. Remember, you're looking at direction vectors, right? 1 and 2. So what do you multiply 2 by to get 1 to get 2? You're looking at direction vectors. The direction vectors here. These are your direction vectors. One and 3, why? 1 and 3, why? So if you multiply this by what? You'll get this? Right? So if you watch here, right? If you watch here, L1 and L3 are parallel. You're not watching here, you're watching here and here. Right? So you're watching these two here. So L1 and L2 are parallel. If I multiply this by 3, I'll get 6 minus 3, 9. That's okay? Right? So L1 and L3 are parallel. Let's check out L1 and L2 now. Everybody okay with that? Let's check out L1 and L2. Right? L1 and L2 parallel. L1 and L2 parallel space. L1 and L2 are they parallel? No. Right? L1 and L2 are not parallel. So let's see if they intersect. All right. So what you see earlier? So if they intersect, what you see here? If they intersect, when I solve these two simultaneously, they should have a common point. Okay? So watch this here, please. I'm taking L1 and I'm writing it in the Cartesian form. And I'm writing L2 in the Cartesian form. Sorry, no, not Cartesian, parametric form. Right. So in the parametric form, what will I get? I will get x is equal to minus 5 plus 6 lambda. Correct? That's okay? And then I will get y is equal to 2 minus 3 lambda. And I will get z is equal to minus 3 plus 9 lambda. Do this one here for me now, Jesse. Put this in the parametric form. Y is equal to and z. Right, question. How do we know if they intersect? If they intersect, then I could get a value for lambda and mu that will make each of these points equal. That makes sense? If these two lines intersect, then they should have the same x, y, and z value. So to have the same x, y, and z value, I should get a value for lambda and a value for mu that will give me all of these being the same. That's okay? So I am trying to find values for lambda and mu that will make x, y, and z equal on both sides. That's okay? So the first thing I'm gonna do is I'm gonna say that. So minus 5 plus 6 lambda is equal to minus 5 minus 2 mu. The reason I'm writing this is vice mirror. I'm writing this here because I'm saying that these two things equal. I'm doing it here too. 2 minus 3 lambda is equal to minus 4 plus 3 mu. So I'm saying that these two here equal and these two equal. And I'm going to solve for lambda and mu. When I solve for lambda and mu now, I'm going to put it in here. If I put lambda in here and I get 5, when I put mu, I'm supposed to get 5. That means that they intersect. Right, Keshav? What are we going to do again? Right? Keshav, I'm just doing this. Watch. I'm making the x equal, I'm making the y equal, and I'm solving it. Right? When I get lambda, I'm putting it here. When I get mu, I'm putting it here. If they're equal, they intersect. If they're not equal, they don't intersect. That's okay? So what would I get here? That 5 will go across there, that'll give me 0. So I'll get 6 lambda is minus 2. So I'll get mu to be minus 3 lambda. That'll be 0 divided here. So mu is minus 3 lambda. Here, I could simplify this out. I'll get minus 3 lambda is equal to, when I cross it 2, I'll get minus 6 plus 3 mu. Right? I could plug in mu here, Marquis. I could plug in mu here, and I will get minus 3 lambda is minus 6 by 3. I'll get minus 3 is equal to minus 6 minus 9. Do your thing on that side, you'll get 6 lambda is that, lambda is minus 1. Right? All of these are solved simultaneously, right? And again, mu to be 3. Plug in minus 1 here, and I get mu to be 3. Right? Check it back and make sure, right? So I made mu the subject here, and I substitute mu in here. Right? And I should get this, right? Check it back just to make sure. Minus 9, that gives you plus 9 plus this. Minus 1 should be right. Right? Now I'm going to check and see if Z values are the same. So I'm going to check and see if it's consistent or not. Right? So I'm going to put minus 1 in here. So for L1, Z is equal to minus 3 plus 9 by minus 1. I got minus 12. And I'm going to do the same thing for L2. L2 is minus plus 3 minus 5 by 3. 3 minus 15 is minus 12. What does that mean? Therefore, the consistent and L1 and L2 intersect. Pardon me? So then you are, no, it can intersect again. So then your objective now is to find 2 and 3 and see if they intersect or they skew. Are you okay with that? Victoria? Follow what to do? Keisha, follow what to do? Right? If these two are not the same, they're not consistent, they don't intersect. If they don't intersect and they're not parallel, they are what Prescott? Yes. They are what? They don't intersect and they're not parallel. They are skewed, right? Okay. Right online, copy down this, and I want you to check out L2 and L3. Same process. By real cool way. Yeah, so but L1 is minus 5. Copy it down. Copy down fast, Javed. This is L2 and L3 to do. Marquis. Marquis. Right online, all I want you to do is message if it is L2 is queued or not, right? Who's that? Oh, you have to do all the thing first now? Yes, ma'am. You have to do L2 and L3. See if they're parallel, or if they intersect. Or if not, is what? Is skewed. Oh, yeah. About L2 and L3, that should be. Only one signal. Right, so put it in parametric form, make the x and y equal. So. Because when he was very question about. Yeah. L2 and L3. Crack it on. About capital stuff all the time, right? Yes, right, then we can finish it. Something else? Huh? Nah, give me some time. Online, so all I want to do is just message if it's in the sec or if it's queue. Chelsea, remember it'll be L2 and L3 behave like that, right? Let's check out L2 and L3. Announcing what we're gonna do. I'm not just announcing that boy. I can announce. Oh, by the way, while I was here, right? While I was here, if they ask for the point of intersection, if they ask for the point of intersection, we just need x, y, and z value. We know z is minus 12, so we can easily find anyone you want, x and y, right? Right, so we can find x here, minus 1 by 6, minus 5 is minus 11, and this is 5. Right? So just in case they ask for the point of intersection in doing this. Okay. All right, you can give them the point of intersection if it intersects. Oh yeah, I'm just waiting for a few more online and then we can do that, right? Hey, still writing down this? I gotta stop. No, I'm gonna.
So you have to. And I give her. And you don't mind her. I get what you got. I didn't get something. I didn't get something. Yeah. Okay.
Right, time up. Up. Time is up. Why would I do that, man? A man's wouldn't do that, man. Why are you taking so long, man? No, what's in your right, so I'm using L1, L2 and L3. So that would be 2 plus 2 gamma minus 3 minus gamma. Darian, stick right now, boy. Right. So I have L3 and L2. I'm going to equate them. So that'll be 2 plus 2 gamma minus 5 minus 2 mu. Minus 3 minus gamma is minus 4 plus 3 gamma. I mean, mu. Right, so we have here what? We have 2 gamma is equal to minus 7. Minus 7 minus 2. Everyday class finishes 7. Except Ash Wednesday, every day is 7. Right, true, we have class. Last. Right, if I make gamma the subject here, I will get 1 minus 3 mu. I'm gonna put gamma in here, so polygon fraction.
Yeah.
Polygon 9 on 4. 9 on 4. Right, and minus 23 on 4. Right, so let's check Z. Here is 2 W's. Okay, I spelled it wrong in the beginning somewhere then. Nah, 2 W's. It looks like one. Right? So that's skewed. Right? Because these two values are not the same, right? Yeah, because I'm wrong. Let me see now. Anybody got these values? Chelsea? You got these values for mu and gamma?
What went wrong?
Everything. Very correct.
Yeah. I just like to be up with the player.
I know, I'm going to share, right?
Wait, they cut it out? And Jack was saying, now that's the same thing as Jack was saying. Why you cut it out? Really?
Cut it up.
It's not, oh, no, because it's like, when it's like, it's like.
Jesse, what you got? Where? Well, I put gamma here to be positive, and I get 1. Huh? No, I put the minus 4 here, become positive. I'll get 1 minus 3 mu. So when right, I put this here, right? And I move this here. And I move the gamma. 1 minus 3. Right, check what you're working. Let me see. Yeah, Chelsea. Okay, nice. Questions? Trouble? Trouble? Right, that was bad. Let's go again. Copy it down. I'm gonna give you another one. Alright, some of you all get in trouble to solve simultaneously. Do but this one here, please.
I know. You ready out of it?
I'll put it on the board. Oh yeah. I'm gonna copy it out. Give me the next one. Let me see who will go on. Yeah.
Yeah. Yes. I do. I never have.
Online, any questions? Right, just take your time and solve simultaneously, right? Peter, you have this already? Please try the next one. On the board. Right.
Why is it not our only sport before once?
Next one on the board. Nice. All right, let's go. Next one here. Up on the screen, up on the screen. Last one. Last one before I change it. Same thing. Right? He just branched out into the IGN people. Come on, everybody, we have this.
Iba yun, no?
Yes.
Yeah.
Wash. Buying up already. Victoria, you finished? Marquis, can you one question for the class summary? One question.
Impression me. It wasn't so really.
Anybody knows the thing, run to the bell?
Yeah. That's it. 1 second.
But when you know, I know she didn't like it, when you're.
No, yeah, this, it sounds like I would today.
Oh. Uh-huh. Looking at you. Finish.
And check.
Gravity finished. Please remember, the first thing you have to say is that they are not parallel, huh? Right? They're not parallel, right? And I'm gonna do it in 2 minutes. Victoria, what you got? No, Victoria, come here. Come here. What you got? And the second one up. All right, let's see what you got. Right, they should intersect, right? They should intersect. All right, so I wrote them down here. Let's work it out here. So this is minus 2 plus 2 lambda. This is 8 minus 6 lambda. And this is 1 plus 4 lambda. Here, this is 4 plus 5 mu. This is 3 minus 2 mu. And this is 6 plus 3 mu. Okay? And then we're going to try to solve. So we'll say that minus 2 plus 2 lambda is equal to 4 plus 5 mu. Right? So 2 lambda is equal to 6 plus 5 mu. Lambda is equal to 6 plus 5 mu. All over 2. Right? Not looking too nice, but right, should be able to still solve it here. Make these two equal. 8 minus 6 lambda is equal to 3 minus 2 mu. Minus 6 lambda is equal to minus 5 minus 2 mu. I know what lambda is, so I'm going to put it in here. Right, so I'm going to take this lambda and put it in here. So I'll get minus 6 open brackets by 6 plus 5 mu all over 2 is equal to minus 5 minus 2 mu. This is minus 3 minus 18 minus 15 mu is equal to minus 5 minus 2 mu. Bring everything on one side, you'll get minus 13 mu is equal to so mu is 1 minus 1 mu. Oh, this lambda was a fraction. Right, so if mu is minus 1, we can find for lambda. That'll be 6 minus 5 and 2, which is a half. So lambda is a half and mu is minus 1. So we're going to check now. We're going to check for consistency. Right, so for L1, Z is equal to 1 plus 4.5. So we got 3 for L2. For L2, Z is equal to 6 plus 3 by minus 1. Therefore, they are consistent, which implies that they intersect. So we need to get a point of intersection. We need to get a point of intersection. So we need the X, the Y, and the Z. Right? We already have the Z is 3. Right? X and Y now. Right? It doesn't matter which one you use, you'll get the same thing, right? For mu as minus 1, you'll get X as minus 1. Put minus 1 in here, you'll get 5. Right? If you choose minus 1, put it in here. Right? If you choose a half, you'll end up with the same values. Right? Put a half in here, you'll get minus 1. Put a half in here, you'll get 5. So the point of intersection is minus 1, 5, 3. That's it. Yeah, they asked that up. That's part 2. You okay with us? Yes. Right, so I'm going to ask you a question again. Right, you guys have it. So Marquis, these 2 points intersect, right? Yeah. These 2 points intersect. How do I find the angle between them? All right, so you get in there. So angle between the 2 lines, right? So cos theta is equal to the dot product over the product of them. Right. Question. What is A and B?
A is. I think, no, A is 2, -6, 4, and B is 5, -2.
Right, so we are going to use the direction vector. Very good. Right? So note that. You all remember this formula? Yeah. Right. So in order for us to find the angle between those two lines, Marquis said to use these two direction vectors. That makes sense, Darian? All right. Do that command return. Do that command, I'll give you a break. Right, Marquis. Very good, Marquis. Right, very good, Marquis. All right, just more paper and I'll just work on that and I'll give you a 5-minute break. I'll give you a 5 minutes and then we do the last thing in module 2. Esther, you okay with this? Yeah, you good? All right. Hamlet, you okay?
What's that?
Hamlet, are you there, Hamlet? Yeah. Right, look out the angle here at Cafe. Come on, boy. I'm giving you a break. You can sell it, you can sell it some during the break. I mean the sell the thing during the break. Huh? Oh yeah, look out the angle, man up please. Look out the angle there. I get it.
5, 2, 4.
That's a user for the right? Vamos chegar aí. Telephone. 6 by 7. 1 How much all I got here?
84.
All I got here. With what? 56?
Yeah, 56 by your tickets. I think so, I might be wrong.
Yeah.
Sì, vedere proprio che mi piace.
Cancel again.
34.6.
That's the angle.
34.6 degrees. Yeah, that's not bad.
Alright, nice. Take a little break, 5 minutes, and then we start back.
They like they say you're ready to come to the. Yeah.
So where could it even?
5 minutes. Right, 5 minutes break, right online. And then we finish last thing. That is 5 minutes. Let's start back. Right, let's take a look at vector equation. Let's start. Vector equation of a plane. Alright, let's start on it. That's vector equation of a plane. All right, so far we looked at the vector equation of a point, a line. Now we're gonna do it for a plane, right? Right. You understand it? Plane. You know what plane is? Right, watch this here. Here's what we're looking at now, right? Are you watching? Watch here, Marquis. We're trying to find the vector equation of a plane, right? So imagine this iPad here as a plane. Okay? We're trying to get the equation of this plane. So far, we found the equation of a point, one single point. Right? That was a position vector. Then we found the vector equation of a line. That's what we've been doing all the time. Vector equation of a line, right? Now we're going to combine all these lines, a whole set of lines, to form a plane. That's okay? Yes. Huh? So far, we found the equation of a point and a line. Right? That's what I'm just trying to show you all there. The equation of a line is a point on the line and the parallel vector. Right? Right? Suppose now you had a large amount of lines. Right? If you had a large amount of lines, they would form a plane. If you have a large amount of dots, they will form a line, right? And if you have a whole set of lines, they will form a plane. A plane looks like this. So if I ask you to find the vector equation of a plane, you need two things. A point on the plane and a vector that is perpendicular to the plane. That's okay? So those are the two things that we need. A point on the plane and a vector that's perpendicular to the plane. That vector will be perpendicular to every single line on the plane. Every single line. Are you okay with that? So we're going to attempt to find that equation. Right? Head up vector equation of a plane. Right? Head up vector. Right? That is your plane. You have a vector here. Right? Let's say this vector is n. That vector is perpendicular to anything on that plane. Right? Let us choose now a random, any point A and a random point R. Right. How do we find Ishana? How do we find AR? AR is what? AR is a vector on the plane. How do you find AR? Well, we need to know A to O and O to R. Right? That's what we did in the last one, right? So let's call it A and R. Right? What is AR? AR is what? Based on this vector diagram here. Based on this diagram. A to O to R. All right. This is just a plane. I just draw the dimensions. I just draw the X, Y, and Z axis here for you, right? That's okay. So you said AR is A to O plus OR. So AR is equal to AO, which is minus A plus R. That's okay. Or I could write it like this. I could write AR is equal to R minus A. That's okay. Everybody okay with that? Why, Darian? Why you get lost, Darian? Darian, I have a vector that's perpendicular to the plane, a point on the plane, and a random point R. AR is A to O plus O to R. A to O are going against the arrow. Right? Right? O to A is equal to A. Right. Yash, what do we know about AR and the vector N? What do we know about the vector AR and N? Yeah. No, remember I told you this vector is perpendicular to everything on this line, right? On this plane. So what you can say about this and this? The perpendicular. Okay. So since AR and N are perpendicular, because remember every vector on this plane perpendicular to N. Okay, that? What does that mean now, Faith? What does that mean? If AR and N are perpendicular, what does that mean? You can probably ask Keshav if you can figure it out. If you can figure it out. Keshav? You didn't figure it out. What do you know if the perpendicular? If AR and N are perpendicular. What you can say? But we are now Jaden then. Jaden. If two vectors are perpendicular, then what do we know?
One.
Somebody say anything between.
What?
Vectors.
Yeah, and then
Right, thanks Chelsea. She said the dot product is 0. Well, I said somebody saying something there. Somebody said it, Victoria or somebody. Not you. Right. Anyway, they are perpendicular. Right? They are perpendicular. So when you multiply AR by N, you'll get 0. What's AR again? Right? AR is equal to R minus A. Right? AR is equal to R minus A. And well, N is that perpendicular vector, right? When you multiply this out, you'll get Rn minus, you'll get Rn minus AN is equal to 0, or you'll get Rn is equal to A by N, right? Right? This is what we call the vector equation of a plane. That's okay? It'll look like this. So what do we need to get the vector equation of a plane? Right? What do we need? Right? We need A and N. Right? We need A, we need a pointer on the plane, and we need a perpendicular vector to the plane. That's all we need. We just need these two things to find this. This. That's all we need, right? So that is the vector. I'm going to show you how to do it. And then we're gonna get the Cartesian.
Okay, right, no, not.
Copy it up. Right, so I'm going to show you when you copy that down, how to find the vector equation of the plate. Right, we have an example there, and we'll do this one together, right? And when you reach there. Yeah, I'm going to do this one here. So what is the example here? Gordon Bradley.
Man, no joy.
Right, what you see all there as an example, right? Darian, what you see as an example? So you want to get the vector equation of the plane, right? Right? So you want to get the vector equation of the plane. So we're going to use R by N is equal to A by N. Right? Here's A, here's N. Here's A and here's N, right? So R by N, N is 721, 7I plus 2J plus K. And A is what? A is here, right? A is 3I minus 4J plus 2K. And you multiply it by 10. That's okay? This is the vector equation of the line.
Yes.
If I want, right? That's how it's not diagram.
Yes.
Right? If you want, you can multiply this out and you can turn it into the Cartesian equation of the line. So watch this here, right? R is what? R is x, y, z. Right? R is x, y, z. Here is 7, 2, 1. You gotta remember how to multiply the vectors. 3 by 7 is minus 4 by 2, 2 by 1. Right? So that's 23 minus 8, so that's 15. You're okay with that? So the last part is this. 7x plus 2y plus z is equal to 15. That is called the Cartesian equation, right? I'm not going to. Oh yeah. Copy that down, right? Yeah. So that's the way you find the vector equation of the line, right? Yeah, finish everything. I can't go there. Alright, let's go back to the equation of a plane. Try that there. All these are past papers, right? You're doing part C, ignore the one on top. Ignore the one on top, you're just doing part C. Right, there's 2014 or 15, right? Lion, hurry up now, boy. Okay, 2014 number 4 part C. I think. Javid of Irene.
Yes, he can talk. He wasn't.
Right, so identify with A and identify with N, and you're done. Huh? And if you want to put perpendicular to, yeah. Okay, Jacob. Right, pay attention to what they wanted. They wanted vector form. Next one. Right, who I pick on Jacob? What A here? A is what? A is 1301. N is what? N is right here, right? So it's R by N. So you can write it like this: R by 2I plus 4J plus 5K. A is 130, and the vector is 2, 4, 5. So that'll be what? 2 plus 12, 14. That's it. So your final answer is R by 2I plus 4J plus 5K is equal to 14.
Yes, I get that, I get that.
Huh? Oh, but what? 2 by 1 and 4 by 3.
I did.
And add it. Right? That's the vector equation and the shot done packing up already. And one more shot. One more shot. That's when I'm done. Last one then. Till 2016, I think.
Yeah, because I'm from the speech. I can go get it.
I have last one, Samira. Can I hurry up, please? Don't go.
I get you good to say.
Well, yeah.
Which way you gonna get it?
Yeah, let's do it fast.
Huh? Alright. Yeah, yeah.
16, you get 16. Or it should have something perpendicular.
No. The dot product.
Dot product is 0, right? So you're multiplying R by what? And multiply R by AB and it should get 0. Right? So when you multiply R, which is 0
Buddy.
minus.
But I know stuff.
Yeah. No, stop.
I know, I didn't know stuff, but it did it too fast.
Or go. Find the dot product. Find the dot product of both of them and see what you get. Right, question, Darian asked a good question there. Should we multiply R by the points ABC or the vectors AB and BC? The vectors, right? Not the points. Good question, Darian. Right, so it means that R is perpendicular to everything on the plane. Faith. Faith, what are we going to use? Or do I pick somebody? Pick somebody online. Bradley.
So why I always want to be the first pick?
Bradley absent. Bradley.
Yes, sir.
Yeah, Bradley, tell me what you're going to use for R and N in the formula.
Or N is and it'll be A B by.
Right, again, this over there.
I'm gonna type for this. So I'm gonna type for this.
So can I come on, let's go.
So N will be A B by B C.
And it's what?
A B by B C.
Just message and then right. I don't know why I'm here. So what you saying? This here is N. What's that all here? Yeah, I'll finish I already. Multiply both of them and I guess 0. I know what the answer is.
How you know that?
You got to work it out. And it's what? N is R. Right? N is R. Right? What do we use as Victoria? Victoria, what do we use as A? What do we use as A? Faith, pay attention, please. What do we use as A? Do we use AB? Do we use BC? Or do we use the points A, B, and C? Points, right? Always remember, A is a point on the line. Okay? So we're using R by A is equal to, sorry, I meant R by N. Right? And then you multiply it out. R is X, Y, Z. N is 0 minus 16 minus 8. N is 0 minus 16 minus 8. And A is what? I will use 3 minus 1. It doesn't matter. You can choose any one you want. You can use A, B, or C. Okay? So your final answer will be minus 16y minus 8z is equal to zero in this case. All right. So in this case, you will get 0. All right. So